The topic is volumes of solids of revolution, the disk method. So let's read the definition. First, the definition says the volume, if we have an area that's revolved about the x-axis, then the volume will be equal integral from a to b of a of x dx, such that the area, if we cut through x, an arbitrary x, we're going to get a disk, and the area of this disk a of x is equal pi times the radius square. So let's illustrate using this example. Find the volume of the solid obtained by rotating the region bounded by y equals square root of 25 minus x squared. So first let's graph y equal square root of 25 minus x squared. By the way, if you square both sides, let me do it here. Y is equal square root of 25 minus x squared. If you square both sides, you get y squared is equal 25 minus x squared. All I did, I'm squaring both sides. And then move the minus x squared to this side, or x squared, so you get x squared plus y squared equal 25. So this is a circle of radius r equal 5, and the center is 0, 0. However, y equals square root, so if you solve this, you get a minus or plus, square root of 25 minus x squared. So this is just the upper circle, so basically it's this part, but we're not going to need this part. You'll see why, because we're going only from graph y equals 0, which is the x-axis, and then x equal 2, so from x equal 2 to x equal 4. So in other words, this is the region that's going to be rotating about the x-axis. Well, first, this is about x-axis. Alright, so how do we do this? First, notice that, let's just graph it so it becomes a little bit easier. So if you graph it, what I'm gonna do, I'm just gonna graph the whole circle. 1, 2, 3, 4, 1, 2, 3. I know I don't need. So this is like a circle, but all I need is this part from here to here. So we're gonna have a volume that look like kind of like a ball, but a piece cut off. So again, if we're looking for the volume, we need to know what is a of x. So the most important thing is to find the radius, because we know a of x is equal pi times the radius squared. So the radius, if we cut through an x here, the radius will be of the disk that we're gonna get, it will be from here to here, right? So it's actually just y, which is equal square root of 25 minus x squared. So my radius is 25 minus x squared. Since the radius is that, then a of x is equal pi times my radius squared. And now this becomes so easy because the area is going to be going from a to b, in this case from 2 to 4, pi, the radius squared, 25 minus x squared, square dx. Let's do this. So this is integral from 2 to 4 pi. If you square the radical, you get whatever it's inside, so 25 minus x squared dx. So the area, the volume, this is a volume, of course, this is the volume. So the volume is equal integral from 2 to 4, so I'm going to distribute 25 pi minus pi x squared dx. And we know how to finish this. This is 25 pi is a constant, so it's 25 pi times x minus, use the power rule here, pi x squared becomes x cubed over 3, and you want all of this to be between 2 and 4. Now this is equal, plug in the 4, 25 pi 4 minus pi 4 cubed over 3, all of it minus, and then plug the 2, 25 pi times 2 minus pi 2 cubed over 3. Now just use your calculator, and that should be 94 over 3 pi. And that's it for this example.